What's up YouTube, welcome back. In today's video we're going to continue the CompTIA PenTest Plus module on TryHackMe. We're still in the application-based vulnerability section, and in today's room we're going to cover the OWASP top 10 room, where we're going to learn about and exploit each of the OWASP top 10 vulnerabilities and the 10 most critical web security risks. Task number 1, Introduction. So this room breaks each OWASP topic down and includes details on what the vulnerability is, how it occurs, and how you can exploit it. You will put the theory into practice by completing supporting challenges. So we're going to cover injection, broken authentication, sensitive data exposure, XML external entity, broken access control, security misconfiguration, cross-site scripting, insecure deserialization, components with known vulnerabilities, and insufficient logging and monitoring. The room has been designed for beginners and assume no previous knowledge of security. Check that. Let's complete. On to task number 2, accessing the machine. So we're going to connect to the TryHackMe platform via the VPN, via our OpenVPN file. Go ahead and complete, or you can connect using the Kali machine, which will require a membership. On to task number 3. Severity 1, injection. So injection flaws are very common in applications today. These flaws occur because user-controlled input is interpreted as actual commands or parameters by the application. Injection attacks depend on what technologies are being used and how exactly the input is interpreted by these technologies. So some common examples include SQL injection. This occurs when user-controlled input is passed to SQL queries. As a result, an attacker can pass in SQL queries to manipulate the outcome of such queries. Command injection is another one. This occurs when user input is passed to system commands. As a result, an attacker is able to execute arbitrary system commands on application servers. If an attacker is able to successfully pass input that is interpreted correctly, they would be able to do the following: access, modify, and delete information in a database when this input is passed into database queries. This would mean that an attacker can steal sensitive information such as personal details and credentials. And then execute arbitrary system commands on a server that would allow an attacker to gain access to user systems. This would enable them to steal sensitive data and carry out more attacks against infrastructure linked to the server on which the command is executed. The main defense for preventing injection attacks is ensuring that user-controlled input is not interpreted as queries or commands. There are different ways to doing this. You can use an allow list. When input is sent to the server, this input is compared to a list of safe input or characters. If the input is marked as safe, then it is processed. Otherwise, it's rejected and the application throws an error. Stripping input is another defense. If the input contains dangerous characters, these characters are removed before they are processed. And let's go ahead and complete that. We understand injection attacks now. On to task number 4, OWASP injection or OWASP command injection. Command injection occurs when server-side code like PHP in a web application makes a system call on the hosting machine. It is a web vulnerability that allows an attacker to take advantage of that made system call to execute operating system commands on the server. Sometimes this won't always end as something malicious like a who am I or just reading of files. This isn't too bad, but the thing about command injection is that it opens up many options for the attackers. The worst thing they could do is spawn a reverse shell to become that user that the web server is running as. A simple command like the netcat-e/bin/bash is all that's needed for an attacker to own your server. Some variants of netcat don't support the -e option, but you can check out this hyperlink to view alternative reverse shells. Once the attacker has a foothold on the web server, they can start the usual enumeration of your systems and start looking for ways to pivot around. Now that we know what command injection is, we'll start going into the different types and how to test for them. So we'll go ahead and complete that. On to task number 5. I already started the machine, so let's go ahead and go over task number 5. So blind command injection is when the system command made to the server doesn't show the response in the HTML document. While active command injection does show the response, the vulnerability can be made visible through HTML elements. In a scenario where Evil Corp develops a web-based shell, they accidentally leave it out leave it exposed to the internet, and it has the same command injection vulnerability as before. However, this time the response from the system call can be seen on the page. The sample code from evilshell.php is causing active command example. As we can see in the pseudocode, the above snippet is doing the following: checking if the parameter command string is set. Number 2, if it is, then the variable command string gets what was passed into the input field. Number 3, the program then goes into a try block to execute the function pass-through command string. You can read the docs on the pass-through on the PHP's website, but in general, it's executing what gets entered into the input, then passing the output directly back to the browser. Number 4, if the try does not succeed, output the error to the page. Generally, this won't output anything because we can't output the standard error or standard error, but PHP doesn't let you have a try without a catch. So, ways to detect active command injection. Active command injection happens when you see the system call response. In this code, the pass-through function passes the response directly to the document so you can see the result. We can use some useful commands to learn more about the machine. Although the pass-through function may not always be the cause of the vulnerability, it was the easiest and simplest way to demonstrate it. So here's some commands that we can try. And then to complete the question below, navigate to this URL. How many non-root, non-service, non-daemon users are there? So we'll go ahead and run cat etsy password. Let's see if that'll show us. From this output, we can see that there is none. So go ahead and enter 0. What user is this app running as? Go ahead and run who am I, www-data. Let's go ahead and copy that. What is the user's shell set as? We can also run this again and look for www-data. As we can see here, www-data, we see that the shell is user sbin no login. What version of Ubuntu is running? We can run lsb release-a. It'll show Ubuntu 18.04. It'll show 18.04.4. So we'll go ahead and copy this. So this is the version. Last question, print out the message of the day, MOTD, message of the day. What favorite beverage is shown? So we'll do a cat etsy MOTD. That doesn't work. Let's go ahead and go back to hint. 00-header. Let's go ahead and do Ellis Etsy MOTD maybe. Then as we can see here, we have 00-header. So we'll go do cat etsy update-motd.d and then 00-header. And then there is the header. So print out message of the day. What is the favorite beverage as shown? So Dr. Pepper makes the world taste better. So it is Dr. Pepper. So we'll go ahead and enter Dr. Pepper. On to task number 6. Task number 6, broken authentication. So authentication and session management are essential for modern web applications. Authentication verifies user identities and provides access to the application, typically using a username and password. A session cookie is then used to track the user's actions. If an attacker finds a flaw in the authentication mechanism, they could gain access to sensitive data. Common flaws include brute force attacks, weak credentials, and weak session cookies. To prevent these attacks, web applications should enforce strong password policies, implement automatic lookouts or lockouts after a certain number of attempts, and then use multi-factor authentication. Go ahead and check that, and on to task number 7. So let's go ahead and start this machine up. So let's go ahead and terminate our current machine and then start this machine up. Broken authentication practical. Developers can forget to secure user input, which can leave applications vulnerable to attacks like SQL injection. However, we'll focus on vulnerabilities on a vulnerability where a user can easily re-register an existing account with a slight modification, giving them the same privileges as the original user. For instance, by adding a space before the username admin, a new account is created with the same access rights as the original user. So to see this in action, go to the following URL and port. So go ahead and open that in a new tab. Try to register a user named Darren. So go ahead and copy Darren. You'll see that the user already exists. So then try to register a user Darren with the space in the front, and you see that you are now logged in and will be able to see the content present only in Darren's account, which in our case is the flag that you need to retrieve. So what is the flag that you found in Darren's account? And now if we try to do Darren and then email, we can just do fake@fake.com, and password can be password. The user's already registered. Now if we do Darren with the space in the front and then fake.com, the fake@fake.com, and then the password is password. So that allowed us to register with the Darren account with the space in the front. So if we put Darren again with the space in the front and our password, now we can see that we logged in as Darren, and there is our flag. If we can copy it, doesn't look like it can copy it. Let's view page source and copy it that way. Now try to do the same trick and see if you can log in as Arthur. So let's go ahead and log out, then register Arthur, and then same fake password or bad password. Now let's put a character in the front of Arthur, a space character, and then register. Now let's go ahead and try to log in with Arthur with the space in the front, of course. And we can see now that we logged in as Arthur as well. Same thing, we can just view page source and then copy the flag and enter that. And bam, task 7 complete. On to task number 8. Sensitive data exposure. Let's go ahead and start this machine. But first, before we do that, let's go ahead and terminate our pre-existing machine. Let's go ahead and start it now. So sensitive data exposure occurs when a web application accidentally reveals private information such as customer names, financial information, or login credentials. This can happen in many ways, including hacking techniques like a man-in-the-middle attack or exploiting vulnerabilities in the web application. Sometimes sensitive data can be even found directly on the web server. The web application in this box contains one such vulnerability. Deploy the machine, then read through the supporting material in the following tasks as the box boots up. So complete task number 9. So task number 9, sensitive data exposure, supporting material 1. So databases are a great way to store large amounts of data for web applications, and most use SQL syntax. Flat file databases are stored as single file or as a single file on a computer and are easier to set up than full database servers. However, if a flat file database is stored in a location accessible to website users, anyone can download and access it. The most common flat file database form is SQLite, which can be queried using the command line client SQLite 3 installed on Kali. Okay, so let's suppose we have successfully managed to download a database, ls-l, file example.db. We can see that there's an SQLite database in the current folder. To access it, we use SQLite 3 and the database name. So SQLite 3 and example.db. From there, we can see the tables in the database by using the .tables command. As seen here, .tables. At this point, we can dump all the data from the table, but we won't necessarily know what each column means unless we look at the table information. First, let's use pragma table info customers to see the table information. Then we'll use select star from customers colon to dump the information from the table, or semicolon. We can see from the table information that there are 4 columns: cust ID, as shown here, cust name, credit card, and password. You may notice that this matches up with the results. Take the first row, so Joy Paulson. We have the customer ID, which is 0. We have the customer name, which is Joy Paulson, the credit card number, and the password hash. In the next task, we'll look at cracking this hash. Task number 10. In the previous task, we saw how to query an SQLite database for sensitive data. We found a collection of password hashes, one for each user. In this task, we will briefly cover how to crack these. When it comes to hash cracking, Kali comes pre-installed with various tools. If you know how to use these, then feel free to do so. However, they're out with the scope of this material. Instead, we'll be using the online tool CrackStation. This website is extremely good at cracking weak password hashes. For more complicated hashes, we would need something more sophisticated. But the password hashes in today's challenges are MD5 hashes, and so CrackStation should be able to handle those. So this shows you how to use it. So we copied the password hash as shown here, and we pasted it into the text field. Complete the CAPTCHA, and then boom, it shows that the password is password. We see that the hash was successfully broken and that the user's password was password. It's worth noting that CrackStation works using a massive word list. If the password is not in that word list, then CrackStation will not be able to crack that hash. And I'll go ahead and complete on to task number 11. It's now time to put what you've learned to practice. Have a look around the web app. The developer has left themselves a note indicating that there is sensitive data in a specific directory. So go ahead and copy the IP and paste it into the browser, into the new tab. It says welcome to sentence sensitivity. Let's view page source and see if we see anything. Nothing here. Let's go ahead and go to the login page. Let's just do an admin test. Nothing invalid credentials. Let's view the source page here. Must remember to do something better with the database than store in assets. So saying that the database is stored in assets. Let's go ahead and navigate to that directory. So let's go ahead and download this webapp.db. This looks like it's going to be our flat file database. And then open up a new tab. Move the web app DB file to the current directory. Now let's go ahead and run SQLite 3 as we saw before in the previous task, and the web app database file. Go ahead and zoom that in, and then we'll do dot databases. Now we see the home invite documents TryHackMe OWASP database. So nothing here. Let's go ahead and go to tables, view the tables. So we see sessions and users. Now we'll use pragma table info of the users table, semicolon. Now we see the user's ID, username, password, and admin. Now we'll just go ahead and do select all from users or users. Now we have all these hashes over here that we see. So the user ID, the username, the password, and then admin. So go ahead and copy that, whether it's an admin or not. Go ahead and zoom that in. Go ahead and create a text file, nano stu creds. Now we see we have this admin hash. Let's go ahead and paste this into CrackStation and see if we can crack the admin hash. So go to crackstation.net. Go ahead and paste it. I'm not a robot. And then crack the hash. Cool. Now it looks like we found a valid password. And then we have admin and QWERTY UIOP. So what is the name of the mentioned directory? Let's go to assets, navigate to the directory found in question. What file stands out? Be webapp.db. Use the supporting material to access the sensitive data. What is the password hash of the admin user? Crack the hash. What is the admin's plain text password? It's that weird QWERTY UIOP. Login as admin. What is the flag? So now that we're in the, let's go back to the login page. Login as admin, and then the password, the QWERTY UIOP that we found. We see over here that we found our flag. And on to task number 12. So let's go ahead and terminate our current machine and then start this one. So an XML external entity XXE attack is a vulnerability that abuses features of the XML parsers / data. It often allows an attacker to interact with any backend or external systems that the application itself can access and can allow the attacker to read the file on that system. They can also cause denial of service or DOS attack, or could use XXE to perform server-side request forgery or SSRF, inducing the web applications to make requests to other applications. XXE may even enable port enabling or port scanning and lead to remote code execution. And there are two types of XXE attacks: in-band and out-of-band, or OOB-XXE. And an in-band XXE attack is one in which the attacker can receive an immediate response to the XXE payload. Number 2, out-of-band XXE attacks, also called blind XXE. There's no immediate response from the web application, and the attacker has to reflect the output of their XXE payload to some of the other files to own the server. Now go ahead and deploy that machine. Complete. On to task 13. Task number 13. Before we move on to learn about XXE exploitation, we'll have to understand XML properly. So what is XML? XML, or eXtensible markup language, is a markup language that defines a set of rules for encoding documents in a format that is both human readable and machine readable. It is a markup language used for storing and transporting data. So why use XML? So XML is platform independent and programming language independent. Thus, it can be used on any system and supports the technology change when it happens. Number 2, the data stored and transported using XML can be changed at any point in time without affecting the data presentation. Number 3, XML allows validation using DTD and schema. This validation ensures that the XML document is free from any syntax error. Number 4, XML simplifies data sharing between various systems because of its platform-independent nature. XML data doesn't require any conversion when transferred between different systems. Syntax. Every XML document mostly starts with what is known as an XML prologue, or the following. So this is an XML prologue, and it specifies the XML version and the encoding used in the XML document. It's not really required to use, but it's considered good practice to put that line in all of your XML documents. Every XML document must contain a root element, for example, the following. In the above example, the mail is the root element of that document. To, from, subject, text are all the children elements. If the XML document doesn't have any root element, then it would be considered wrong or invalid XML doc. Another thing to remember is that XML is a case-sensitive language. Like HTML, we can use attributes. Like HTML, we can use attributes in XML too. The syntax for having attributes is also very similar to those to HTML. For example, the following. In the above example, category is the attribute name, and message is the attribute value. Full form of XML, it'll be eXtensible markup language. Is it compulsory to have XML prologue in the XML documents? No. Can we validate XML documents against the schema? Yes. Can we specify XML version and encoding in XML? Or how can we specify XML version and encoding in the XML document? That'll be to use the XML prologue. On to task number 14. Task number 14, XML external entity, or DTD. Before we move on to start learning about XXE, we'll have to understand what is DTD in XML. DTD stands for Document Type Definition. A DTD defines the structure and the legal elements and attributes of an XML document. Let us try to understand this with the help of an example. Say we have a file named note.dtd with the following content. Now we can use this DTD to validate the information of some XML document and make sure that the XML file conforms to the rules of that DTD. Below is the given XML document that uses note.dtd. A new element, it'll be element. How do we define a root element? It'll be a docu type. It defines a root element, or doc type, my bad. How do you find a new entity? It'll be entity. On to task number 15. Now we'll see some XXE payload and see how they are working. The first payload we'll see is very simple. If you've read the previous task properly, then you'll understand this payload very easily. As we can see, we're defining an entity called name and assigning it a value of feast. Later, we're using the entity in our code. We can also use XXE to read some file from the system by defining an entity and having it use the system keyboard or system keyword. So we're defining entity with the name read, as we can see. But the difference is that we're setting it to a value to system and the path of the file. So path system in the file. We're using if we use this payload, then a website vulnerable to XXC normally will display the content of the file etc password. In a similar manner, we can use this kind of payload to read other files, but a lot of times you can fail to read files in this manner, or the reason for failure could be the file you're trying to read. Right, go ahead and complete that. And then task number 16. Now let us see some payloads in action. The payload that we'll be using is the one we saw in the previous task. So example, here is an example. On the left side, we see that burp request that was sent to the URL encoded payload, and on the right side, we see that the payload was able to successfully display the name Falcon Feast, as we can see right over here. Now try to read etc password. So now we're going to try to read etc password as shown here, and it is URL encoded. On the right side, we can see that etc password is shown, or the contents of the etc password. Try to display your own using any payload. Okay, so go ahead and open this new IP into a new tab. So we're going to try to display our own name using any payload. So let's go ahead and type doc type and then replace the entity name with invite. And then go ahead and close that. Then user info. Then name. Go ahead and submit. Now it shows invite. See if you can read the etc password. Go ahead and Google XXC, read etc password. Payload all the things. Go ahead and click raw. Open this up as a raw text. And then let's go ahead and submit this. And now we see that we dumped the etc password. So what is the name of the user in etc password? We can see a user by name Falcon. What is where is Falcon's SSH key located? So in this output, since it's showing the home directory of Falcon, we can go ahead and but before we copy that, so here's Falcon's home directory. We go ahead and remove etc password, type in Falcon, and then the SSH directory is usually in the home directory, so .ssh, and then let's go ahead and look up ID_RSA. And go ahead and submit, and then now we have a private RSA key. So it's going to be in home Falcon.ssh and then ID_RSA. That is typically the generic or default name for a private user SSH key or private RSA key. What are the first 18 characters for Falcon's private key? The first 18 characters. And submit that. And that is task number 16. We're going to go ahead and end the video here at task 17. We'll start back up here on broken access control. Hope you learned something, hope you enjoyed, and we'll see you in the next video.